Hello, everybody. Mr. Rubo here, and today we're going to look at 3.3-14, and we'll start with the practice proof here. So we are looking at triangle KNP. It's isosceles with base NP, and then KA is the median, and we are trying to prove that KA is also the altitude. So we're going to go ahead, state what's given. And because it's given, we know that, there we go. I'm sorry, because of the fact it's isosceles, we know Kn is congruent to Kp, and that's if triangle is isosceles, then two sides are congruent. If we keep going, Ka is the median, awesome, and because of that, we know that Na is congruent to Pa, and that's if a median, then it divides opposite sides into two congruent segments. Ka is congruent to Ka. That is our reflexive property because that matches. And then at this point, we do have all three corresponding sides congruent. So we can say that the two triangles are congruent to each other by SSS. And we had that in steps 2, 4, and 5, or where we got those sides congruent. All right, but we're still trying to get that the two, or that Ka is an altitude. So we can say that angles KAN is congruent to angle KAP by CPCTC. And then we also know that those same two angles are supplementary to each other because they form a straight angle. So if two angles form a straight angle, they are supplementary. And then because two congruent angles that are supplementary, that means they are both right angles. So if two angles are supplementary and congruent, they are right angles. And then because we have that right angle formed, then we have an altitude by really the definition of an altitude. But if segments form right angles, then it is an altitude. All right, so there is page 14. We're going to go on. Now, I want you to try 15 on your own and check the key with it. You are just stating like side, side angle, side, based on the given information. And again, there's just these quick 5, and you shouldn't have too much of an issue. Okay, and use the given information, but also use the diagram along with it. Okay, so now the next thing, we're going to skip a couple pages and go to page 18, and we're going to go ahead and try this warm-up. So I'll work through this one with you guys, but I would recommend pausing the video and then trying it on your own, and then coming back and seeing if you got it right. But I will work through it just in case if you have issues. So we're trying to show that angle A is congruent to angle ABC, or possibly not. So we know CBD, so this angle here is 10x plus 107. Ooh, man, not great writing here. Okay, ABC, which is this angle here, is negative 7x plus 1. We are told BC is a median, so that means those two are congruent. And we are told BD is an altitude, so that means this right here is a right angle. We are also told that BAC is, which is this angle here, is negative 5x plus 13. Okay, so now we are trying to see is angle A congruent to angle ABC. Well, we do know that we have a right angle because of the altitude. So let's go ahead and set up that equation. 10x plus 107 equals 90. Okay, and let me just make sure I wrote it down right. Yep. So we get, 108, and that would be 3x equals 90. Subtract it. And what is that? Negative 18. Divide we get x equals -6. Okay. And then we just need to see if angle A, which is here, is it the same as angle ABC? So angle A is -5 times -6 plus 13. So that's 30 plus 13, so 43. And the other one, -7 times -6 plus 1. Last I checked, -7 times -6 is 42. 42 plus 1 is indeed 43. So our answer is yes. So hopefully you did this one on your own, and hopefully you did get the same as me. All right, and then the last part of today's notes that I will do with you guys is we're actually jumping ahead to 3-35, right near the end of your packet. And this one we're going to do a little bit of a coordinate proof. Now with coordinate proofs, it's dealing with a coordinate plane, lots of distance formulas, lots of slopes possibly. But yeah, so we are told triangle ABC, we have vertices A, B, and C. They're -2, 6, 6, 4, and 0, -2. And we are told AD is a median to BC. So we want to prove that the two triangles formed are actually congruent to each other. So first thing we want to find is the midpoint, which we'll say is point D, because it's connecting A to D. So we find the midpoint, and it is 3, 1 when we do that. And then we can draw in AD. And now it's just a matter of finding all the lengths of each of the two triangles. So we know AB is, you'll do the distance formula, and you'll end up getting 2 root 17. BC, you end up getting 6 root 2, and AC, you end up getting 2 root 17. Now you'll notice I only did AB and triangle ABC, not actually even going smaller. But the reason why is because I can see that triangle ABC is isosceles with base BC, because AB is congruent to AC. And then BD is going to be congruent to DC because we have a median, so half of 6 root 2 is 3 root 2. And because of that, and the reflexive property, we now know that triangle ABD is congruent to triangle ACD by side, side, side. Or you could even do angle C is congruent to angle B because we have isosceles triangles, which then we get the same conclusion by side angle side. So you'll see a lot of times we can do this a few different ways. You could also have done, you could have found BD and DC separately and seen that they were congruent as well. That would have been another way. All right, and then so here we have AD is also an altitude to BC, prove with coordinate geometry. So here we kind of build it off the proof we just did, but we can just find the slope. So measure the slope of AD, we find the rise over run, it's -1. The slope of BC ends up being 6/6, which is 1. Those are opposite reciprocals. So we do indeed have perpendicular lines. All right, that was it. Thanks for watching, and have a good day.